What's going on, everyone? In today's video, we're going to be taking a look at percentage error, and this is often a very, very easy type of problem to mess up on, but as long as you pay attention to the steps and know the formula, which is provided in the book for AISL, you will get this kind of problem right every single time if you follow these instructions. Let's go ahead and jump right in. So the percentage error formula is given to us, at least in the AISL formula booklet, as VA minus VE all over VE. You take the absolute value, so all that means is that if it's a negative number, you make it positive, and you multiply by that 100 to give it a percentage value. So E is the exact, A is the approximate. Another way of doing this is also, this is for a percentage change, is you take new minus old all over old. If you take your new value, subtract it from your old value, and then divide it by your old value, and of course multiply it by 100, you'll get a percentage change as well. It's a formula that operates in parallel. So now let's go ahead and take a look at this example. So the fraction 22 over 7 is often used as an approximation of pi, and that's true. So you can see when I take 22 over 7, I get 3.1428571. Okay, and then pi is 3.14159. So it's accurate up until that third decimal place. So it gets it up to 2 decimal places, but then it starts to fall apart after 3. That's where the approximation becomes less reliable. So that would be the answer for that part A. So now what we want to do is we want to find the percentage error of this approximation, giving your answers to 2 decimal places. So now, let's think about this. VA minus VE. So the approximate value. Well, 22 over 7 is our approximation. So let me draw this. So I have 22 over 7 is my approximation. My exact value is pi. And I'm going to divide by pi. And I'm going to multiply that by that 100 to give it a percentage value. So let's go ahead and take a look at what that looks like in our calculator. So I'm going to take 22 all over 7. 22 over 7 minus pi all over pi. I'm going to figure out what that is. I'm going to multiply 100, and I'll get 0.04. Okay, so that's going to be 0.04 percentage change. That is my answer to 2 decimal places. So here is my percentage difference. So it's actually very, very, very accurate. 0.04% is not that bad. So that's how you figure out that problem using the formula. So let's take a look at a different type of problem where we want to calculate the density of a cube of sugar, and it weighs 2.45 grams. The side of the cube is 1.2 centimeters. So let's calculate the density. And then we want to calculate the density with mass over volume around to 1 decimal place, and then find the percentage error in those 2 different types of measurements. So let's go ahead and let's figure out what the density is here. So my density for my first one is mass over the volume. Well, I also know that my cube here, excuse my crude drawing, is just 1.2, 1.2, and 1.2. So I went ahead and calculated that volume, multiplied all 3 of those sides together. I get 1.728, and that is going to be pretty good because my mass I'm given is 2.45 grams, and I'm dividing, put that as grams, dividing by 1.728 cubic centimeters. And then what I'm going to do is just divide those in a calculator. And what I'll get is 1.4, I can even make this more specific, 1.41782 grams per cubic meter. And that would be my exact value for this problem. So now I want to calculate density with mass and volume rounded to 1 decimal place. So I want to calculate this to 2.5 grams all over 1.7 cubic centimeters. And what that is going to do is that is going to give me 1.47 grams per cubic meters. But again, I want my answer to be to 1 decimal place as well. So that would be 1.5 grams per cubic centimeter. So now the question is, what is my percentage error between these 2 different methods of calculation? So my error is going to be equal to my approximate. So my approximate is going to be the one where I rounded. So that would give me 1.5 all over 1.41782. Excuse me for getting tongue-tied. Divide that all over 1.41782 times 100. And what that is going to do is that's going to give me an answer of 5.8%. So just by rounding to 1 decimal place in the calculations and the answer as well, that is giving me almost a 6% error, which is quite significant when you think about it. But that is how you would go about calculating percentage error using the formula, as well as what you need to do in the problem to account for different rounding methods and then using that for the percentage error. Okay, so I hope that sheds a little bit of light, and I hope that the examples are now a little bit more straightforward. And I'll see you all in the next video.